The Open University of Hong Kong's Institute of Research in Innovative Technology and Sustainability recently hosted its first annual scientific conference. In the following conference presentation, Dr. Chan Hon Fai, chairman of the Advisory Committee on Water Resources and Quality of Water Supplies for Hong Kong, overviews the sources and treatments of Hong Kong's water supply and discusses the testing and monitoring regime that assures its high quality.
What I'm going to talk about here is drinking water quality management protocols and standard here. And just to share with you my work in the advisory committee and what the works that WSD is doing for Hong Kong people, right? Okay, the topic today is briefly here. First is the sources of water in Hong Kong and water treatment process. Second is water quality monitoring and control. Third is water quality standard and water safety plan. And lastly is the laboratory quality management system. Right, so we get 70% of water from Dongjiang and the rest of the 20 to 30% from our rainwater in catchment area. Now, this is Dongjiang. We extract water from a point called Tai Yuen Pump Farm, which is in Dongguan Kiao. And then we have a dedicated aqueduct here. We transfer water from Tai Yuen Pump Farm all the way to Shenzhen Shui Fu, and then through two pipes to Mok Wu Pump Farm, and then to Hong Kong. All right. So, Kiao Tao, right, is where we abstract water from Dongjiang, and Guangdong province attach high degree of importance. They take it very seriously here. And there has been regular meeting here between Hong Kong and Guangdong on the quality of water supply and the quantity of water supply. Now, so this is a picture showing the abstraction point, Tai Yuen Pump Farm. And this, in fact, this picture here shows you the profile. So here is Tai Yuen Pump Farm. So it has to go through 4 pumping stations here to pump the water up and then all the way down to Shenzhen Shui Fu, right? So it's a major construction works that started in 1965 something, right? And in fact, the special aqueduct was built in 2000 and finished complete in 2003 for the latest aqueduct. Right, this picture in fact shows you the Mok Wu Pump Farm, where we obtain the water from Shenzhen Shui Fu. And here you can see colleagues in water supply department taking water sample for routine inspection, examination of water quality. This is the bird's eye view of Mok Wu Pump Farm. Right, I think if you are interested in visiting this Mok Wu Pump Farm, you can probably apply to water supply department. I think they can arrange, but this is in a restricted area, so therefore you have to get special permission to visit. But I think it's worthwhile going there because you will find a number of online monitoring equipment here doing online real-time monitoring of some of the water quality parameter, particularly nitrogen, turbidity, the number of parameters that they monitor online. And from there here, they can give signals to their colleagues in the water treatment plants. So as to say, for example here, if they detect high concentration of manganese here, they can probably inform their colleagues in water supply department, perhaps to add more chemical to precipitate the manganese from the water. So therefore, they have a real-time station there. Now, this also shows some of the online monitoring equipment here. One on the left-hand side is ammonical nitrogen, and one on the right-hand side is the one that detects artificial radionuclides, like cesium-134, right, and 137, and iodine-131. Now, this, in fact, they use a multi-parameter water quality monitoring system here to measure water quality simultaneously. They have at least 6 sensors: dissolved oxygen, chlorophyll A, pH, turbidity, conductivity, and temperature here that can feed the data into their system here. This shows the multi-sensor equipment here, and that shows you how they get the data from the sensor and through modem here and to their logger, right? And then therefore they can go through a SCADA system here to translate the data to other laboratory for comparison or for reference. All right. Now, on the local sources here, we got the water from the water gathering ground. In fact, 1/3 of the total area of Hong Kong is for water gathering, and the water will drain into our impounding reservoir, 17 of them. And total capacity of our reservoir is 586 million cubic meter. Now this, in fact, shows you some of the reservoir. One is Dai Lam Chong, Sek Bik, right? And High Island, Clover Cove. Clover Cove and High Island take up about 80% of the total storage capacity of the impounding reservoir. The rest cover only 20% only, right? And the area in green are the water gathering ground. So therefore you can see that it covers, in fact, about 1/3 of the total area of Hong Kong. And these are protected area here. Now this picture here gives you a schematic diagram of the freshwater supply system here. So therefore you can see that we have the rain that will collect it through the catchment area here to the impounding reservoir here, and then will go to the water treatment works for treatment, and the water from Dongjiang will go through Mok Wu Bun Fang and then go to water treatment works for treatment, and then to go to primary surface reservoir, and then to surface reservoir, and then to various households for consumption. That's the typical freshwater system in Hong Kong. Now, here we have show you a typical water treatment process. I won't go to the detail. Basically here, what WSD is doing is, first of all, to pre-treat the water using chlorine or ozone for treatment here. And then we've gone through a coagulation and flocculation, clarification and filtration. And then afterward here is a pH adjustment, disinfection, and fluoridation here to protect our teeth. Right. So that gives you the typical process here. Basically, they use the alum, right? Alum and hydrated lime, right? Chlorine for disinfection and pre-treatment, fluorine for fluoridation here. That's a rapid mix chamber, flocculation tank. These are the typical process here, right? So I won't go into details into that. Now, after the water is filtered here, one thing I want to mention about is that we'll adjust the pH by hydrated lime to about 8.2 to 8.8. This is for protection of our pipe well, right? And afterward here, we will add fluoride to the water for dental protection, and the target is 0.5 milligram per liter. And there will be a small amount of chlorine added to the water before delivering out of the water treatment well. And this is to provide some protection of the water during the delivery and short storage at the surface reservoir. And the target concentration is about 1, perhaps 1.2 milligram per liter, right? To maintain the some protection for the water supply. But perhaps you have heard some time ago, a year or two ago here, where there were some residents complain of white cloudy water, yeah, in the supply, and that probably was caused by the short section of the pipe well where the chlorine may be too high, because as you deliver the water from the water treatment works to the household here, the chlorine may dissipate, right? Dissipate and gone. So if the pipework is too short here, the chlorine may not have dissipate enough, and that may cause the cloudy, the white, murky situation. Right, this is a typical picture showing a few treatment work. One is Sha Tin. Sha Tin is the biggest water treatment works, and OUHK is another one. One thing particular about OUHK is that it used ozonation here for disinfection here and sedimentation here. And there was also a Daibo water treatment work using DAF, biological treatment here. So these are some of the more special treatment works. Right. Now, we've gone through a vigorous treatment and monitoring of the water quality before leaving the water treatment works. One thing is they take water sample, regular water sample at the treatment work outlet here to test that this water quality comply with the World Health Organization standard 2011, so-called WHO 2011 here. And for the past 16 years here, we have examined the water quality twice every year, right? Twice every year. Make sure that the water quality comply with the WHO before we permit sub-university to publish the water quality data into their web. And so far, I've seen here, there's been no exceedance, right? First of all, here we check that the raw water from Dongjiang comply with the water quality standard in China, right? And in fact, we also check that the water quality after treatment from the water treatment work here comply with the WHO. So far there's been no exceedance. So therefore, I was surprised, in fact, last year here when I heard that our drinking water exceed the WHO standard for land, and that I was taken by surprise, because so far I have examined the water quality for so many years. There was no exceedance at all. Right? So that triggered a series of investigation, right? And we finally found that the lead, in fact, did not come from Dongjiang and did not come out from the treatment work, but it came out from the solder joint and the copper alloy fitting in the internal pipeline or the surface pipeline to the consumer. And that was, you can say we had done a lot of hard work, but finally here we found these causes. Now, although in retrospective here, it has been a hard work here, I think in the long run here, it served Hong Kong a purpose, because after finding the causes for the lead contamination in drinking water, we learned a lot, and citizens, the people in Hong Kong, are more aware of the quality of the water that they drink. And I think this is something that I think we have achieved, is that people are aware of the quality, and people pay more attention to water they drink. And in a way here, they put more pressure and more attention to the works in the water supply department, right? We can also say that Hong Kong enjoys one of the safest drinking water supply in the world. We can claim that. Now, particularly on the quality of water supplies, right? Water supply. Now, we have to distinguish the quality of water supply and quality of water we drink, right? So now this is some of the online water quality analyzer that WST is using. So I don't want to go into detail on that. Now, this, in fact, picture showing the location of the water treatment works. There are 22 of them and some tens of laboratory. And the location are shown here. This picture shows you 14 laboratories for 4 radiation screening centers doing the chemical, physical, biological, and bacteriological and radiological testing here. right? And the equipment using state-of-the-art and analytical equipment here. And this picture here shows you the routine water quality monitoring program that they are doing, including, as I've said earlier here, one at Mok Hua, one at the catchment area, one at impounding reservoir, water treatment works, distribution system, and consumer tap. But of course, the distribution may not be even. So perhaps we have done a lot of monitoring at the impounding reservoir, catchment area, water treatment well, but we don't have much on consumer taps, because sometimes it's not possible to go into consumer's tap to take water sample. So we've been putting pressure on water supply department to get more sample, but more data from the consumer tap in order to ensure that the drinking water that they consume fulfill or comply with the WHO 2011 standard. So these are the types of the analysis that they are doing. Physical, chemical, biological, bacteriological, and radiological analysis. Right, these are some of the equipment here. On heavy metal here, they use ICP, so-called the inductive coupled plasma mass spectrometer here, ICP, and also gas chromatographer, the GC, which I think some of you are familiar with. Okay, these are the high-performance liquid chromatography for pesticide, and ion chromatography for chemical like iron bromase, this kind of anions. This shows the gamma monitoring system here, and the low-level alpha-beta gas proportional counting system here that they use. All right. Now, in fact, this is also one thing particular and special in Hong Kong is that WST developed a biosensing alert system using superfish to detect any anomaly in the water quality. So if they detect any abnormal movement of the zebra fish, they will immediately take sample and make sure that there's nothing toxic or contamination in the water. They have also developed another biosensing system, and that is the bacteria, because they use a bacteria which normally would luminate, so-called bioluminescence. So if there's some chemical which inhibit the bacterial growth, so this bacteria will emit less light. And if something happens here, they will provide an alert system here for the technicians here to take action here. So we follow the drinking water guideline, the WHO standard, and this WHO is a well-researched and a consensus of opinion of 490 leading experts here. And so this is the basis for our drinking standard. And last year here, or early this year, there's been a comment that should we review the WHO, and I think this is ongoing, and we will also look at it under the international expert panel here. All right, this is the standard, right? So the standard consists of provisional guidelines for 89 health-related chemicals, 1 bacteriological parameter, and 2 radiological screening parameters for drinking water, right? And next, I'll go through briefly the Safe Drinking Water Plan. This is a big topic which I cannot cover a lot here, because here this only talk about the water safety plan for WST, which is to have a system assessment, monitoring, and management system, and we'll have input from the health department here, and the support from various colleagues in department here, in government here. But there should be another framework here from the photo construction industry. All right. So this is in fact a very complicated system here, which WST will review, and the international expert panel, which I'm a member here, will also examine this water safety plan. So I don't go to in detail. But in fact, as soon as early as 2007, WST has been implementing a WSP for Hong Kong already. So objective here is to minimize contamination and reduce removal and of contamination and prevent
contamination during storage and distribution of the drinking water. Right? And we publish the water quality data twice in a year after our advisory committee examined the data. Right? So here, I won't go into detail of this laboratory system, which is basically they follow the ISO 9001 integrated quality management system. Yeah? Now, finally here, I have two short slides here for a summary of my talk. First is that I think all you agree that WSC is committed to supplying the public with water that is clear, wholesome, and free from pathogenic organisms here. The water that we draw from Hong Kong, from the Hong Kong as well as from Dongzhuang here, provide nowadays here 100% of the water that we consume. And each year here, WSC takes 160,000 samples for analysis to make sure that the quality comply with the WHO standard here. And they have developed a water safety plan to ensure that the water from source and through water treatment to distribution is safe to consume. And the water that we drink comply fully with the WHO guideline for drinking water 2011 here. And the laboratory in WSD follow the ISO IEC 17025-2005 standard here. And they also follow a laboratory information system, so-called the LIMS system, for the archive of data, distribution, disposal, analysis, all sorts of things for the water quality data. And I think so much for my talk. Thank you for your attention.